we will be learning about the pressure law. The pressure law is also known as the Gay-Lussac law because it is named after the French scientist Joseph Louis Gay-Lussac. And you might be expecting a joke, but I don't have any joke for that. So our objectives today are to 1. State the pressure law, 2. Sketch graphs of the pressure law, and 3. Apply the pressure law to solve problems. So the pressure law says, for a fixed mass of gas at constant volume, the pressure of the gas is directly proportional to the absolute temperature. So our graphs of the pressure law will look similar to ones that we have seen before. This graph should remind you of the graph of Charles' law. The pressure is directly proportional to the absolute temperature. And remember that absolute temperature means that it is measured in Kelvin. So since it is directly proportional to absolute temperature, then you have a straight line graph that passes through the origin. Meaning that if the absolute temperature is 0 Kelvin, then the pressure would be 0 pascals, atmospheres, whatever it is measured in. If the pressure is measured in pascals, atmospheres, or whatever, but the temperature is measured in degrees Celsius, then it looks like one we have seen before with Charles' law, where you have a straight line, but it does not pass through the origin because the coldest anything can get is minus 273 degrees Celsius in theory. So it would have an x-intercept down here at minus 273 degrees Celsius. It would not pass through the origin. So both graphs will be a straight line, but their difference is, just like with the Charles law, if it's absolute temperature in Kelvin, it passes through the origin. If it's degrees Celsius, it does not pass through the origin. It has an x-intercept of negative 273 degrees Celsius. Let's look at some examples now.
A canister of nitrogen gas has a pressure of 2,000 psi, pounds per square inch, at 20 degrees Celsius. What will the pressure be if you increase the temperature to 25 degrees Celsius? Let's write down Gay-Lussac's law, P1 over T1 equals P2 over T2, because we have a before and after. Remember to convert the temperatures to Kelvin. Kelvin equals degrees Celsius plus 273.15. So T1 equals 293.15 Kelvin, and T2 equals 298.15 Kelvin. Substitute in what we know. 2,000 psi over 293.15 Kelvin equals P2 over 298.15 Kelvin. Solve for P2. Multiply both sides by 298.15. P2 equals 2,000 psi times 298.15 Kelvin divided by 293.15 Kelvin. P2 equals 2,034 psi. Here's another example. At 10 degrees Celsius, a gas exerts 0.95 atmospheres of pressure. At what temperature in Celsius will it exert a pressure of 0.75 atmospheres? P1 over T1 equals P2 over T2. Remember, we have to convert temperatures to Kelvin. Kelvin equals degrees Celsius plus 273.15. So T1 equals 283.15 Kelvin. 0.95 atmospheres divided by 283.15 Kelvin equals 0.75 atmospheres divided by T2. Solve for T2. T2 equals 283.15 Kelvin times 0.75 atmospheres divided by 0.95 atmospheres equals 223.54 Kelvin. We're not done yet. Remember, we have to convert our temperature back to Celsius. 223.54 Kelvin minus 273.15 equals negative 49.6 degrees Celsius.